Now we've explored differentiation, and what we've now got to do is apply it to maximum and minimum problems. So these are questions where you have to put the equation that you are going to be differentiating together using the information that they give you in the question. So in the question, they have given you x plus y is equal to 12. And they've also given you a second equation. A is equal to x squared plus y squared plus 3xy. Now, the approach to this problem is to, in the first instance, to extract these two equations from the problem and write them down. So we have x plus y is equal to 12. And then we have a is equal to x squared plus y squared plus 3xy. And when you've done that, you need to read the question more carefully, because now you have a focus. And the question here says, and this may not say it in the exam. In the exam, you may have to second guess this for yourselves. But this, what it says here is write a as a quadratic function in x. And at the moment, what we have is we've got a as a quadratic function in x and in y. So when they say to us, write this as a quadratic function in x, they are telling us not to have y anymore. So what piece of information have they given us where we can actually focus and find y? And this is when you look to the other equation. So we want to basically, if we don't want y, in the other equation, the one that I've just highlighted, the y in red, we want to isolate y, put it on its own. So the y is going to stay where it is, 12 is going to stay where it is, and the x is going to move over the equal sign to become minus x. And now we've made y the subject of the equation. And having done that, we can now use that on the second equation, a equals, which we're going to do now. So we're going to have a is equal to x squared plus, we need to get rid of the y. So the y is now 12 minus x, all to be squared. And then we've got plus 3x, and there's y appearing again. So therefore that now becomes 12 minus x. Because I don't want to do a load of working out going all the way down the page, I'm now going to work out the 12 minus x to be squared off to one side and then substitute the answer in. So go find some available space. I think over here will do. 12 minus x all squared is equal to 12 minus x on 12 minus x. Expand it out, and we have 12 on 12 is 144. Minus 12x, minus 12x, and a minus and a minus is a plus, x on x is x squared. Tidy it up, x squared minus 24x plus 144. Now what we're going to do is going to do a is equal to x squared plus, open bracket, because when we substitute into brackets, x squared minus 24x plus 144. Close bracket, and then what we're going to do now is expand this one out. 3x on 12 is plus 36x, and 3x on minus x is minus 3x squared. So tidy up line, so we've got x squared plus x squared minus 24x plus 144 plus 36x minus 3x all squared. So area is equal to, well, x squared plus x squared is 2x squared, minus 3x squared is minus 1x squared. Minus 24x plus 36x is plus 12x. And then we're left with plus 144. Plus 144. It does say here, hence calculate the maximum value of A. Hence calculate the maximum value of A. Now, we know this is a quadratic, and it's a negative quadratic, and so therefore we don't have to test for a maximum because we already know it's going to be a maximum. We need to find the maximum value. Last year, we could have used completing the square for finding the maximum value. We could do that now, but now it's actually quicker to differentiate it. So we are going to do dA by dx, and that's going to be minus 2x plus 12. If you do go into automatic pilot and differentiate a second time, d2a by dx squared, it's not the end of the world. The answer is minus 2. Minus 2 is less than 0. Therefore, we are going to have a maximum. Okay, what's the formula for a maximum? Well, the formula for a maximum is, well, for local max, and we always quote local min, nothing wrong with that, not even in this problem, don't lose marks for that. For local max, local min, we have dy by dx is equal to 0. But in the context of this problem, it is dA by dx. So the chances is when we actually do this, we will go into automatic pilot mode, whether we like it or not, and we would do dy dx. No big deal. You have a choice. You could just cross it out and put the correct notation in, or you could quite simply just a bit of tip x, and then say, right, I need this to be dA dx is equal to 0. So dA dx is minus 2x plus 12. So therefore, I've got minus 2x plus 12 is equal to 0. So minus 2x is equal to minus 12, plus 2x is equal to 12. Dividing both sides by 2, you end up with x is equal to 6. Now, you need to remember from last year that when they say find the maximum value, that means find the A value. It means find the A value. We know that A is equal to just looking for the formula now. There it is. So A is equal to minus 1x squared plus 12x plus 144. Therefore, A is equal to minus 1 on 6 to be squared plus 12 on 6 plus 144. So calculator time. And assuming I haven't made any arithmetical errors, that should come to 180. Now, the input number was 6. The output number was 180. The output number is always the max or minimum value depending on the problem. So what was the, as the question asked us, hence calculate the maximum value of A. The maximum value of A equals 180. Okay, we're now going on to the example number 2. A rectangular enclosure is formed from 40 meters of fencing, with a wall forming one side of the enclosure as shown. If each of the sides touching the wall is x meters in length, find in terms of x the length of the third side. Don't go diving into this like a bull in a china shop. The first thing is, do I know? Go back to basics, go back to second year. Do I actually know what the length of the third side is? No, I don't. So what do you do? What do you do if you don't know the length of something? Well, you give it a length. So the length is y. Let the length of this section of wall be equal to y. What do I actually know about the length of this wall? What do I know about the length of this wall? Well, it's x plus y plus x. So I know that the length of this, sorry, did I say wall? I meant to say fencing. What do we know about the length of this fencing? It's x plus y plus x. So I know that the fencing length is equal to x plus y plus x. I know that the fencing is equal to 2x plus y. You get 5 marks for that. What else did they tell me? Well, they did tell me in the question that a rectangular enclosure is formed from 40 meters of fencing. So therefore, I know that the fencing is also equal to 40 meters. So what does that mean? Well, 2x plus y is now equal to 40 meters. What was my invention? What did I have to add to the problem? I added to the problem y. That's what I did. I added to the problem the letter y. And if you read the question very carefully, it says find in terms of x the length of the third side. So basically it's telling me I need to isolate the y value. So now I've got y is equal to 40 minus 2x. And find in terms of x the length of the third side. So I have done it. Express the area of the enclosure in terms of x. Well, what is the enclosure? Well, the enclosure is this thing, which is a rectangle. Okay, so there's your rectangle. What's the area of a rectangle is what they're basically saying to you. And of course, we know what the area of a rectangle is. The area of a rectangle is basically your length times your width. So the area of this rectangle is equal to your length, where your length I'm going to take as x, and the width I'm going to take as y. So therefore, the area of this enclosure is x times y. But I know what y is. Y, open bracket, is equal to 40 minus 2x. 40 minus 2x, close brackets. So my area is equal to 40x minus 2x to be squared. And that's a quadratic again. It's a negative quadratic, and therefore it's going to be yielding a maximum value. So express the area of the enclosure in terms of x. Done it. Now it says find the maximum area that can be enclosed, which means find a local maximum or find a maximum. If you see the phrase find a maximum, well, we know what to do now. We differentiate. dA by dx is equal to 40 minus 4x squared. And we may go on automatic pilot. We may, just without thinking, do d2a by dx squared. And we're going to get minus, whoops, I think I made a bit of a boo-boo in that last line. That's when you differentiate minus 2x squared, you get minus 4x, not, multiply by the power, put the power down 1. I broke my own rules. I was so busy talking to you lot. I forgot to multiply by the power and multiply by the power and put the power down 1. Without thinking, you might go and differentiate a second time. If you do, you won't lose marks for it. It really isn't the end of the world. If you're not sure, and it's a simple differentiation, the golden rule is, just do it. It won't do any harm. What do I know? I know that for local max stroke local min, dA by dx is equal to 0. Therefore, 40 minus 4x is equal to 0. So minus 4x is equal to minus 40. So 4x is equal to 40. Divide both sides by 4. So we're going to end up with x is equal to 10. Now, we want the maximum area. The maximum area is going to be given by the input value, x is equal to 10. So the area is 40x minus 2x squared. So when x is equal to 10, the area is equal to 40 on 10 minus 2 on 10 to be squared. So 40 on 10 is 400. 10 squared is 100 times 2 is 200. 400 take 200 is 200. Now this particular problem is making reference to area. So the area, the maximum area is 200 meters squared. So area max is equal to 200 meters squared. Now you can get on with the problems. Thank you very much.